Yeah, so we can commence, right? So yesterday when we met, we discussed some stuff, and we spoke about this. I hope you can see my screen. Can you see my screen?
No, please.
Okay. I remember I gave a research work. Don't worry, I'll talk to you here. So when I'm about to end my session, okay. Now I'll make it something brief today, which because last time or yesterday, as I told you, there are certain things that you won't find in Python, but you see it in C. Okay, so that makes it a little bit difficult. So such things I have to take my time so that you guys can get the concept right. Once you get the concept right, then I can, share whatever thing I want to share with you. So one of the most difficult concepts that we normally talk about in C programming, okay, is pointers. So yesterday we went through functions, if you remember, and I did explain everything to you guys. And I know the research work I gave it to you guys, you want to find out, because definitely I will ask you guys, okay, when I'm about to end my session. Okay, so uh, we got to this place, and this is where we got to, and I said I'll explain this later on. Okay, so let me start with this because I will need the pointers before I'll come here able to get concept to you. Okay, so I'll come back to this call by value and call by reference. If you have any question, you can stop me, okay, and ask. I'll answer you or explain things clear enough. So I believe yesterday's concept was clear to all of us. Give me a reaction if all the things that we did yesterday, it was able to sync well. No problem. Okay, Mamisi, Roland. Okay, all right. All right, so that is good. Great to hear that. All right, so let's start. Now, today's session also, as I said, I'll make it a quick one or a brief one because pointers, as I said, is something that is very, very confusing for beginners, okay, in C. So today's session, I'll go all the way to this place. So that is all. So we are going to do only pointers and indirection operators. So if I'm able to use 1 hour, that'll be all. The rest, I'll give you guys project work for you guys to go and work on. Okay, I just want you guys to get the concept because we'll use pointers later on in arrays and other aspects, okay, in the program. Okay, so we need to get a concept right over here to make sure that at least if I can get 70% or even 80 to 90% of you getting the concept of pointers, I'll be very, very happy. And those of you who are into robotics and also doing more of embedded systems and stuff, you need pointers a lot because you'll be writing code to manipulate the computer memory, okay, which is the hardware, which is firmware, instead of trying to copy data and try to replicating it. Okay, so yesterday I tried to explain a concept to you that most of the variables that we create when we are writing a code, what actually happens is that we normally use a copy of that variable. Okay, we use a copy of it. And I gave an instance where I have a notebook for C class. Okay, now the notebook, if Blessed asks me, I can give a copy of that notebook to Blessed. I won't give Blessed the original notebook. So Blessed has a copy of my note. So whatever Blessed will do with it, I still have my original notebook. But if I give Blessed the original notebook, remember now Blessed has what my original notebook, so he can manipulate, do anything, and any changes Blessed will make in that original notebook, I will see it. But when it's a copy, or if I give a copy of the note to Blessed, any changes Blessed will make in that copy, I will not see it. It will not affect me. You see the difference between the two. So when you try to manipulate data at the address level or the register level, okay, whatever changes that you make, it affects everything. But if you make the changes at the copy level, that means the original value will not be affected. And this is where pointers come in. So pointers come in to make us have the ability to be able to manipulate data at the address level or at the memory level. So any data that you manipulate in the computer memory, it will have a cascading effect, okay, because of using pointers. But if it's a copy of it, mind you, just a copy, so you still have your actual data. All right. So pointers, I mean, the difficulty beginners have with pointers has to do with what? The terminology and the concepts, okay? So the terminology that we use. And I have to be honest with you, I remember undergrad, my time when I was learning it, confusion all around. We have to read before we can get the concept. And it was not even clear till we started doing projects, then things became a little bit clearer, okay, to us. So the most important thing that I want to get from you all is getting the concept, terminologies right, and the concept right. Once you get it, the rest, when we are writing the code or when we are doing any project, I won't have any issue. Okay. So you've all seen this, and I know if I ask anybody to explain this, they will do this for me. Okay, so let me see. Can you explain this statement? Int I is equal to 3. What do you think I'm doing over here? Let me see on the call.
You are declaring a variable.
Come again. Let me see. Or anybody at all can go on to explain this. This line, what do you think this line is doing?
Say I think we are declaring a variable.
You think, that means you are not sure. Say it well.
We are declaring a variable.
What is the variable name? They didn't say anything about the variable name.
I.
And what is the variable storing? You didn't say anything about it.
It's stored in int.
No, what is the variable
It's an
storing?
integer.
The value.
And 3.
What is the type of the variable?
Int.
Int. Thank you. So you see here we have a variable, and the variable is of type integer, and the name or the identifier of the variable is I, and it's storing the value of 3. Okay. Now what is a variable? I did explain this yesterday, that it's a name location in the computer memory. It's a name location in the computer memory where we can store a value of a particular type or a specific type. Okay, so it says name location in the computer memory. That means inside the computer memory, they have locations, and these locations, they have names. So inside the computer memory, we use address for them. Okay, address. So inside the computer memory, you are not going to find a specific value. You first need to know the address. Okay, once you know the address, you know the value that is stored in that address. Okay, so when you take the computer architecture, which they call the von Neumann architecture, there are two important things that we normally deal with. The first one is the memory data register. The second one is the memory address register. The memory data register and the memory address register. Okay, so the memory data register, anytime you store data, okay, we need a place to store it. But first, we need the address, okay, of that data. We need the address of that data. Okay, so if I want to visit, let's say, Israel, first, Israel has a place that he's staying, right? But before I can get to Israel, I need the address or the location of his house. Okay, so the same thing in the computer memory. You store data. Okay, now the data is somewhere in the computer memory, but for you to be able to get the data or get to the data, you need the address where it is stored. So addresses play a crucial role. Addresses play a crucial role. Okay, so the declaration you see over here, int I is equal to 3. This declaration tells the C compiler, 1, to reserve a space, address, okay, in a memory to hold the integer value. Then you associate the name I. This I over here is an identifier. Okay, it's an identifier. So remember, when we are talking about a variable is something that is complex, but identifier is actually the tag. Let me use the word the tag. Okay, so when I say Israel, Israel is a tag. Okay, but human is actually a variable. Okay, so because humans can change. So Israel, I can move to Lamisi, I can move to Roland. Okay, but the tag, your name is a tag. So we associate the name I. The I there is an identifier. Okay, and that is what we are using to identify the location. Then inside that location, we store a value over there. We store a value over there. So three things happening. We need to reserve a space in the memory. We need to give it an identifier. Then we need to store a value in that location. And this thing, I don't know whether I said it last time, that anytime you store a value, okay, what actually happens is that you can if you don't assign any value to it, if you don't assign any value to it, what actually happens is that it's going to give it a redundant value, right? We learned this. It's going to give it a redundant value. So here we reserve a space in memory, we give it an identifier, and we store a value, right? So this is the memory map of a variable. So anytime you create a variable, this is the memory map. So this is the location name, which is known as the identifier. This is the value, and this is the location number, which is the address. So when you go to the computer memory, this address is what we are looking for. This is very, very important, because without this address, we can't get the 3. We can't get the 3. Okay, so this address tells us a lot of, or gives us a lot of information, because it is the address that the computer will now use to get the value. Will get the value. Okay, so we give it a location name. Okay, we have a value, but the address is very, very important, because it plays a crucial role. And it is this address that today we are going to talk about. How do you manipulate these addresses? That is what we are going to talk about today. So if you get this concept, please let me know before I move on. So when you create a variable, three things: the identifier, which is what we use, and I gave an instance of an identifier. So Israel is an identifier, okay, and the value mean what is stored there, then the address. Okay, so these three concepts are very, very important. If you are okay with it, let me know before I move on to go and talk about pointers. Okay, so let's move on. All right, so let's look at this. Now I'll code it right now. Okay, so this is our skeleton, this we have int main, then we have this now. Now when you see this, I want somebody to tell me, when you see the ampersand, how do you call the ampersand? You see, how do you say this? What's the meaning of this? The ampersand. I don't want to mention any name. Somebody should go on to tell me. This one is what?
It means move on to the next one.
Come again. I said, how do you call this? This ampersand.
And
It's not end, please. Did I say end? How do I call this? Adam, are you on the call?
Yes, please.
Okay, tell me. How do you call this? In C,
Um, the address is it identifier?
hi. Please say it correctly for me, okay?
Um, address operator.
Okay, so the address of operator, the address of operator, not the address operator, the address of operator. Now, this, we use it. Which of the, keywords do we use the address of operator? Which of them? Or the reserved words in C that we use the address of operator? Which one? Anybody can go on to answer. Which one did we use? The address of operator. Anytime you're using that keyword, we normally use it.
The scanner.
The scanf, thank you. So the scanf. Now, why do we use that? Remember, I made mention, or I did explain this sometime, that the scanf, we need to append that because it tells C the location, which is the address in the memory, where to go and get the value. So what this thing is actually telling us that return the address of I, not the value. Return the address of I. Okay, so that's why you see this statement. I'll program it. Now, this one too is also going to return the address of I, but the P over there, we are using the hexadecimal value for the address. You know, in the computer system, okay, we have different number system. Okay, most of the time, errors and memory addresses are normally, written in or hexadecimal. Okay, so hexadecimal are more better or concise than using the binary. But when you put it like this here, you're using decimal. That means base 10. Okay, but you can also use hexadecimal. So these two lines, this and this, the same thing, but one of them is printing hexadecimal because of what? The format specifier. Here, the format specifier here is U, telling you that is what? It's an unsigned integer. And here it is P, telling you that it is what? It is hexadecimal. All right. Then here we have this. If you look at it here is I, right? So this I here is trying to tell you that, well, give me the value. So it's going to print 3. I'll run this right now. Then when you come here, this is a little bit strange. Now, we said this one is the address of. Okay, so the address of I. But there's another operator over here, the asterisk. Now this asterisk, we use it in what? Multiplication, right? But we can also use it to do another thing. And I will talk about this. This is known as dereferencing. We are dereferencing. Okay, this, what is actually happening over here, is known as dereferencing. Okay, so in simple terms, what we are saying is that return the value at the address of, that is the meaning. Return the value, okay, at the address of. That means when I go to the address, the specific address over, there's a value over there, return it. Because each address, we put a value over there. Okay, so when you go to that address, there's a value stored, return that. And this is where we use the asterisk. So the asterisk will return the value stored at a particular address. Okay, so when you see the asterisk over here, it's trying to tell you that what? We use the word is following. We say it is going to follow the address. The value that is over there, return it. The value that is over there, return it. So if I should program this right now, you see that here is going to give me the address, but here is going to give me 3, here is going to give me 3. So let me implement it quickly. If you can also implement it, you go along and do that. Okay, all right. I hope it is clear, is making sense, or you are getting the concept small. Are you guys getting the concept small? Okay. So we have I'll make it pointer, like example 1.c. Okay. So I have my skeleton, standard input output. Then the next thing is our int main. Okay, I'm not passing anything to it. Okay. So I'll just declare and assign my variable. Okay, so int I, assign 3 to it. Okay, so let's print the following, which is I'm going to print the address. So print the following, so the address and the value. Okay, all right. So the first thing is, let's try to print. I need a printf, and I'm going to print the address. So the address of I, okay, is then I'm using the format specifier U to indicate that I want the address, which is I, like this. All right, now I'm going to print it one by one for you guys to see. All right, this is how you guys go and find out this. Okay, I'll ask you guys when I'm about to end my session. Okay. All right. All right. So let me compile this GCC pointer pointer underscore size 1. Okay. All right. So pointer, I come here. All right. Which one am I using? Oh no, I'm in the wrong directory. CD group A. So pointer. How did I save it? Okay, I saved it wrongly. Okay, there's one over here. There's also one over here. There's P rather not one. Okay, all right. So, all right. Now look at it. You see the address of I is what? So this is the address. That is the location where the value I is stored. The location where the value I is stored. Okay, so you see this is the address of, so meaning give me the address of where, or the address of I, the address, because when you go into the computer memory, we keep this data at specific addresses. So here I'm returning the address of where I can be found, where I can be found. So if you get a concept, let me know. Okay, then you know I'm always lazy, so lazy people are always, so I just copy and paste. Then here I'll put I over here in what? In hexadecimal. Okay. So it's going to give me the same thing, but remember one of them is going to be a normal digit, as you can see over here. Okay, and this value is unsigned telling you that what, it can only be positive, it can't be negative. That's why I have the U over here. Okay, now the P over here tells you that I will return it in hexadecimal. So let me compile my thing again, and let me run it. All right, so as you can see, are we seeing? So you see this is all return what, the address in hexadecimal value, return the address in hexadecimal value. Okay, so now I have access to the memory. I have access to the memory. In Python, we didn't get that. Python abstracted a lot of things from us. Okay, but in C, I can now see this. Okay, which I have access to my memory now. Okay, so the next thing is I can print the value. Okay, so the value of I is, then I have to just remove this. Once I compile it, okay, and I run it again, see the value of I is 3. Have you seen the value of I is 3 now? Then the last one, which I'm also going to get the value. The value of I is, which here is D, but there's something I did, which I told you known as dereferencing. So I'm bringing the asterisk. So what we are doing over here, as I said, is that here is returning the address, but we use this one to dereference. That means follow the address, go and pick the value in that address. Okay. Follow the address, go and pick the value in that. So this one is going to give me the value because of the dereferencing operator over here, the asterisk over here. It will return the value at that address. Going to return the value at that address. Okay. So let me save it and compile it, and let's see what is going to happen. All right. So sorry, I didn't put this thing over here. All right. Supposed to put this thing over here. All right, so let me compile it again. All right, and we have this. So as you can see, the same thing. So the value, have you seen it? So this is known as dereferencing, which we are going to talk about. Is it clear up to this level? If you have a question, you can stop me and I'll answer you. All right, so if it is clear, let's move on. All right, so here, say the ampersand. The ampersand used in the first printf is the address of operator. I've already said it. So this one returns the address of the variable I. So That means when you go into the computer memory, that address, I need the address where, or the location where that I is. Send me that address, and that is what I did explain. Then we use the U to specify the result. It's always positive. It can be negative, right? Then I also mentioned about the P. If you use the P, it means the return on the hexadecimal format, and I've already shown you, okay, all these things. Okay, so what is the asterisk? The asterisk mean, apart from it being used as multiplication, it also means what? The value at address. The value at address. So the value at that address, return it. So if you look at this code over here, okay, if you look at this code over here, just return the value at this address, because this is going to return the address. Okay, so we say that give me the value at this address. Give me the value at this address. So that is that, which is value at address. It can be used in the printf, as you saw. Okay, that means I use it over here to return the value. So this is known as dereferencing. Okay, so it gives the value stored at a specific address in the computer memory. The value at address operator is also called indirection operator. Indirection operator. Okay, so another term is you are dereferencing. You want to dereference it. Indirection operator. Indirection operator. Okay, so note that the printing of the value, look at it. Okay, is the same as all this. So if you see this and you see this, it means it's returning the value. This is the value, this is the value. No differences between it. Okay, no differences between that. Okay. All right. Any question so far? All right. So silent means you guys are okay. All right. So the next one is we are digging deeper into pointers now. Okay. So we saw that the expression is give the address of the variable I, right? We know it. So anywhere you see this, be able to tell me that I will say this one is going to give the address of the variable I. Now the address can be collected. That is the interesting thing. I can collect this address and store it in another variable. I don't know if you get the concept. The address of a variable I have created, I can collect that address and store it in another variable. So if you look at it over here, this is going to return the address of I. This address that is going to be returned, I can keep it in another variable. Simple. I don't know if you get a concept. The address of a variable can also be stored in another variable. Do you get a concept? The address of a variable can be stored in another variable. So the address of I that I'm returning using this can be stored in J. Does it make sense? Is it clear?
No, please.
It's not clear.
No, please, can you take it again?
All right. So when you see the ampersand I, what is the meaning? It means that the address of that variable. Okay. Now when you go into the computer memory, before you be able to get the value of that variable, you need the address. So what this thing is doing that is returning the address of I. Okay, not the value. I has a value, I has an identifier, I has an address. It's returning the address. Okay, it's the address that the computer uses to be able to locate wherever you store your thing. Because the reason why last time, I don't know whether I said this to you, that the reason we call it random access memory is that the memory, okay, it doesn't access data in a sequential way. It's randomized. And the only way the RAM can be very, very fast is it has to use address. So each data you store has an address. So what we are doing over here is that we are using the ampersand to return the address of I. Okay, and that is what we did over here. Okay, that this is returning the address of I. That means the address that we are returning over here means when I go to that address in the computer memory, I will find the value I over there. So here is returning the address, this one is returning the address. And this address that we are returning, we can also store it in a different variable. Okay, we can also store it in a different variable. I don't know what practical application can I even give. Okay, the address that we are returning, we can also store it in a different variable. Okay, so if you look at the statement here, this ampersand I will return the address of I, not the value. So if you look at this diagram, this is the address of I. This is the value of I. This address, I can also store it in another variable, and that's the variable j. So j is storing the address of I, not the value. J is storing the address of I. But remember because j2 is a variable, j2 will have an address, and this is the address of j. Okay. Remember, anytime you create a variable, the variable will have an address in the computer memory. It also has a value. It also has an identifier. Okay. But what is important to us is the address. Okay, because the address that will enable us to manipulate the data directly. Okay, so I have a variable called I, and I want to store the address of that variable in another variable. So this expression is returning the address of I, returning the address of I, and I'm storing the address of I in another variable called J. So remember, J2 will have an address, and that address will be different. So as you can see over here, this value of J is the address of I, and this is the address of J. I don't know if you get it now.
Yes, please, I get it now.
Okay.
Thank you.
Are we okay? Is it clear? Because if you don't get a concept, you'll get lost along the way.
So
Are
please,
we-
I have a question.
Okay, go on.
For the referencing,
Okay.
and in actual programming, where would it be needed? Because if you would use the asterisk symbol and your ampersand together, in another context, you can just use the I on its own. Where does it actually come to?
Okay, so that is what I said I'll come back to explain. These two, call by value and call by reference. You need to dereference sometimes, because when we are passing argument, yesterday we spoke about, that we have what formal argument, we also have the actual argument, right? So if you are passing an argument, in actual sense, you are passing a copy of your variable. You are not passing the actual variable. So when it happens like that, any manipulation you do will not affect your actual variable. But if you want to affect your actual variable, you need to dereference it. That means go to the memory and get me the value instead of passing a copy to me. This is where the dereferencing comes in. I don't know if you get what I just said. Okay.
Yes, I get it.
You get it now. So it's very important. Sometimes you just want to manipulate the data in the memory, not just a copy of it. You wrote a function for it, but a function will just, you pass an argument, is going to give you a copy of it. You don't want it that way. You want the actual value, okay, in the memory. You need to dereference it, okay, and follow the address to go and get your value so that you can do whatever calculation you want to do with it. All right. So if this concept is clear, please, are we okay here? Because we are moving on and things become complex as we progress. So make sure this concept is clear. Okay. All right. So here I value, so I's value is 3 and J's value is what? Is I address. I've already explained over here. So the value of I is 3, but the J's value is the address of I. Okay. So J is a variable that contains the address of I. J is a variable that contains the address of I. So it is declared as, when you see something like this, you call it a pointer. Okay, so in actual sense, what we are doing is that we are saying that, okay, we are going to declare a variable called J, and that J is going to store the address, okay, of another variable of type int. Okay, so J here becomes a pointer. Okay, let me state it again, okay, so that you get a concept. When you see int asterisk J over here, we know that this one is what? Is the value stored, okay, at that address. Okay, the value stored at that address when you see this. So when you see int asterisk J, we say it's a pointer. It's pointing to int, but it's pointing to a variable of type int. That means the variable that is pointing to, it is storing a value of type what? Integer. okay, is integer. So what we are saying is that this thing is going to store the address of that variable, and that variable is of type integer. So this declaration tells the compiler that J will be used to store the address of an integer value. Okay, it's storing the address but not the value. Don't get confused. It's going to store the address but not the value. Okay, so int asterisk j means the value at address stored in J is an int. Okay, so here we are going to store the address. Okay, once we store the address, we can now use the dereferencing to get the value at that address. Okay, we are going to use dereferencing to get the value at that address. Now, let me try to implement something small for you guys to get a concept, or else we will get lost. Okay, so I'll come back to this place to make sure that things are clear enough, because if you don't get this, I mean, we'll get lost along the way. So let me create another file and call it pointer. Okay, example2.c. All right, so I have my skeleton, standard input. Sorry. Okay. Then int main and void. All right. So now I have a variable. Okay. So I'm going to have a variable which I'll declare my variable and out, and also pointers. Sorry. All right. So I have a variable called what? Int, let's see, number. Okay. Now I'm going to have another one which is a pointer, which is going to be num like this. So this is my variable, okay, and this is going to be a pointer. We normally, conventionally, we normally add PTR to distinguish it, okay, which is a pointer to what? To int. Okay, so what am I doing over here? This is a variable I've declared. Remember, when you declare a variable, okay, C is going to reserve a space in the computer memory that's going to store that for us, okay. So this has an address. This variable has an address. So I'm saying that the address of this variable int num, I want to store it over here. I want to store it in this. Okay, so this is a pointer. What is it pointing to? It's pointing to this variable, and they have to have the same type. Okay, so if your variable is of type int, the pointer too need to have the same type. You can't have two different, one variable, or the variable being integer and then the pointer becoming float. No, it will flag you. Now the pointer is read from right to left. What does it mean? It means that the pointer num ptr is pointing to a variable of type integer. That means I'm going to use the num ptr to store the address of this variable. That is the meaning. I'm going to use this to store the address of this. Okay, but remember that this one too is a variable, also going to have an address. Okay, but I don't care about the address of the pointer now. What I care about is the address of my value or variable over here. Okay, so if, let's assume I do some initialization, which num is equal to what, 3 like this. Okay. Now, remember, this is the value, right? So the value of what? Of num is 3. Okay. So if I want to store the variable, sorry, the address, then I have to call my pointer, which is this, right? Then I can now store my num inside. Is it clear?
Yes.
Does it make sense? Please get a concept before I move on what I've done. So this one, I'm storing the address. So storing the address in the pointer, okay, num ptr. So what, this is a pointer. So what this thing is just going to do, all this while, it's just going to store the address of this. Okay, it's just going to store the address of num. And this is how you declare pointer. This is how a pointer is declared or initialized. Okay, you can initialize, but most of the time we don't initialize it. So here I've declared a pointer to this variable, and I've set my variable that I'm giving a value of 3. So I'm saying that this, okay, store the address of my variable in this. You need to declare it this way before you can store it. If you don't do that, it will flag you. Okay, it will flag you. So we can print them one by one. Let's see, the effect. Okay, so the first thing is we can print the address of I. Okay, so I have my printf. So the address of num is, remember we use what u n n, then we have sorry, what's that now? Okay. All right, so you're going to tell me that this is going to return the address, right? The address of this. So if you are following me, you realize that if I have this, okay, if I have this and I put this thing over here, will it give me the same results? These two, if I should print it, will it give me the same results? If I should print this, will it give me the same, will it return the same thing for me?
Yeah.
Why? Why do you think it's going to return the same thing for me?
No, because the N now is the address for the num, and then the non-PTR is storing the same thing.
Thank you. All right. So the ampersand num is returning the address of the location, okay, for the variable num, and the num PTR is storing the address of the variable num, or it's a pointer to the variable num. So it's going to return the same thing. So if I should compile this and run, I expect that. Okay. All right. All right. So okay. All right. If you look at it, it's the same thing, right? No differences between it. Okay, the same thing. So remember, this is returning the address, but we are using this to store the address of this. Now, somebody is wondering, okay, sir, why don't you let me take this thing from there and let's see what actually happens. Okay, I've removed the ampersand from there and let me compile it and let's see some of these things. Have you seen it? See, he's trying to tell me, no, it can't be possible, right? It can be possible. Yes, it's asking, why are you doing this? Because it's going to store the address. So I need to declare this one as a pointer. I need to declare it as a pointer before I can do that. So that means the asterisk over there plays a crucial role. You neglecting it will not make that variable a pointer to what? To store a variable. Okay. Now, the interesting thing is that the variable keeps on changing. So anytime I compile it, the address, okay, where we are storing a variable will keep on changing. So anytime you compile it, you are not going to get the same address. And your address on your computer will be different from my own. That is something you have to check. So if you look at it, you see the first one, it was different. Now if I should compile and execute again, you see the address has changed. So the address will keep on changing, right? Because it's random, so to store it at a different place anytime you compile it. But it's going to return the address. Okay, it's going to return the address. Are we okay? Are we okay? All right. So let's move on. And now there are two things we can get the value. So let's try to print the value. Then after that, we print the value of this. You're not printing the address. You're going to print the value of this. So we have this. Let me just paste this. Okay. So I'm going to print the value that is stored in the pointer. The value that is stored in the pointer, I'm going to print it. So what I have to do, okay, okay, so this is my pointer. Okay, so I have where is my name? Okay, then I also have this. Okay, so this is going to give you the value, and this is also what? Value. So the value of num and the value of no, these are the value of the pointer. Let me just make the value of the pointer. Okay, so the value of the pointer, and also okay. All right. So here I have to change this. This will give me the same thing because it is the value. So this is the address, but let me try to how do I even put it? Try to change something small so that you guys will get a concept, because I think the explanation I gave first wasn't all that good. So this is going to return the address, right? But remember I said that the num pointer over here is storing the address of the num. So this, what I wrote over here is not correct. Here is supposed to be the value. Okay, this is the value. So the value of num ptr, okay, the value of num ptr, okay, is the address of this. Then the num ptr also has an address, which if I put it over here, okay, if I put that one over here, I can put what, the ampersand in front of it to get the address of the num ptr. Okay, so here become what, the address. So the address of the num ptr it is. Okay, please don't get confused. Oh. Let me take it again. This, as you know, is returning the address. That one you know. But we said we use the pointer to store the address of the variable. So the address that is stored over here is going to be the value of this pointer. So the value of the num ptr is the address of the num. But remember, the num ptr is a pointer. It also has an address because it's actually a variable. And I'm printing the address of that using this ampersand over here to print the address of that. So the value, this and this will be the same, but the address of num ptr will be different from, they are this. Okay, I don't know if you understand where I'm coming from. Okay, so this have to go off. So the value of this, okay, is that. Then the last one, I can do dereferencing now, which I will pick the pointer and I will dereference it. So we expect to have the same thing, okay, which I can dereference over here. Then I can also dereference also over here, which they are the same thing. Okay, so which is reference ampersand this. Okay, all right. So this is returning the address of the variable num, because the num ptr is storing the address of the num. The value of num ptr is going to be the address of the num. So that's why I put the value over here. But num ptr is also a variable, but it's a pointer to int. And remember, since it's a variable, it also have an address. So I'm printing that address over here. Now here, I want to print the value of the num. The value of the num is going to be 3, as you can see over here. Now remember, we use the word asterisk over here, okay, to denote what, dereferencing. I said it. But bear in mind that this is what? Carrying or storing the address of the num. So I use the asterisk to dereference it so that it will return the value for me. So here I should expect to return what, 3. Then when you come here also, oh sorry, I made a mistake. Here might be something like this. Okay, so this is also the address So because this one is the address, it's going to dereference. It's going to dereference this so that it also return what the value for. So if I compile it, okay, I expect okay. So let me go up so that we see the concept. All right. So here the address of num is here, but the value of the num PTR is this. Okay, why is the value? Because we said the num PTR is storing, okay, the address of the num. That's what become the value. Then the address of the num PTR is this. Remember, the num PTR is a pointer, but it's also a variable. It also has an address. So if you look at the two, see, they are two different things. They are not the same. Okay, then the value of the num is 3. The value of yes, shouldn't be num PTR. So the value stored in, let me be specific. The value stored, okay, in num PTR is, and the value stored in num PTR is that. Okay, so here, if you look at where my pointer is, here we dereference, okay, the num PTR because it's a pointer. We dereference to get the value. Okay, then here too, we are dereferencing the variable, okay, address. So here we are dereferencing the variable address to get what the value stored in it. Are we okay?
So happy I got confirmation or something to pray for.
Because I don't want to go further. Okay.
There's no compulsion. You feel you are staying in the year you're right now.
Okay. Are you okay?
They didn't get used to see this one as his classmate. And this one better get used to see Jerry as his classmate.
Are you okay? Miss Clay, please go and bring my my charger downstairs. Okay.
And
Where I'm sitting. Yeah. Okay, I did explain this. So if you look at it over here, can someone try to explain it again to me to make sure that you understand it? Okay. Can someone try to explain what button I did over here? Anybody? Roland, can you go on? Roland? Hmm? Setonam? Setonam? David? Should I start awarding marks? Hey, I'm having a class. All right. So I want someone to try to get this code for me. Who's going to do it? Hello? Roland? Hey, you guys will not talk. Ikuya,
Sir, please, are you asking us to explain the results that is being displayed on the terminal?
not the result, but go through the code for me. From the explanation I've given, can you go through the code?
Uh,
From the explanation
Okay,
I've
sir,
given
please,
so
I
far,
can
can you
try.
get? Okay, go on and try.
So from the beginning, we declared a variable it's num, and then our pointer num ptr, and we've assigned the value 3 to num, and then we assigned the address of num to num ptr. Then the first print statement, we are printing out the address of num. Second one, we print out num ptr, but from the code you realize that num ptr is the same as the address of num, so to print the same. Then we'll also print out the address of num ptr, which would be different. In the next one, we'll print out the value of num. Then for ptr, we'll print the value stored in it. So that's the next print statement. So with your asterisk and num ptr. And finally, you would basically print num again because you have your asterisk and your address of and num.
Dumb boy.
Okay, that is fine. I want a lady to also explain it. A lady, let's be quick. I want a lady to explain this to us. Let's be quick because today, as I said, I'm just focusing only on the pointers so that when you guys can go and digest, try to get a concept before because we use pointers seriously in functions a lot. Okay, because they play a crucial role in functions. Okay, so I want you guys to get a concept well established so that when I'm working on functions where we are passing pointers, which is called by reference instead of called by value, things will become clear enough to you all. So I want the lady to explain it. Should I mention it?
Mention it.
Okay, let me mention it because they are hiding. The ladies are hiding. I don't know why they are hiding. Okay.
Yes.
Um, Mami Esi. Mami Esi on the call? Yes, Mami Esi. Mami Esi, can you explain the code? Mami Esi, can you explain the code?
So I'm here active.
Okay, so go on.
Yeah, so, hmm. So give me a few minutes. So the
Ayeka, ayeka.
who is that? So the int it's like that's where like the computer stores the or holds the integer. And then we have the int as asterisk something something.
Hey, no, please. Don't be saying something, no, please. They have names. Use proper terms, terminologies, please. If you are not using the terminologies, it means you are lost. And how to be honest. So use the proper terms for me. Okay.
So please, and how do you see it?
That is a pointer.
So yeah, the pointer.
Yes, a pointer num-ptr. Okay.
Hmm.
Okay.
The pointer, yeah, we have the int num pointer. Yeah, that. So that one it addresses the pointer and the operator.
Which line are you talking about now? Because I'm lost.
So I'm on the line
Line what?
line 9.
Line 9. Okay.
Mm. So the the address, the first, I think it's line 15
Okay.
and line 16.
Okay.
So they both print the memory of the location of num.
So what do you think num PTR is doing for line 16?
So it's the same thing.
Well, if you say the same thing, explain it well. Say the same thing. I mean, it's not clear to me. What do you mean by the same thing?
So it's printing the value of num PTR.
Explain the value. And what is the value of num PTR?
The location of num.
The address location, not the location. Address location.
Yeah.
Okay.
Mhm.
Okay. So line 17, 16, sorry, 18, 18, 19, and 20.
Should I explain those ones?
Yeah. Yes. Explain each line. Okay.
So 17 is printing the address of the print.
Printing what? The address of the pointer. Num
The
PTR.
point.
Yes. Using those things is very, very important to me. The address of the pointer, num PTR. Okay, go on.
So in line 18, so it's printing the value. The number stored
It's printing
in the num.
Okay, in the num.
The number stored in the num.
Okay.
And then line 19 is printing the number stored in PTR.
The number stored in a pointer, num PTR.
Yeah,
so what term is that? I use a term that when you see that, what are we doing?
So PTR.
There's a term I use for this. This whole expression.
The pointer.
No. Adam, can you tell her for me?
Is it dereferencing?
Yes, I'm dereferencing the pointer. Okay, so I'm dereferencing the pointer to pick the value out. Okay. So let's move on to the next line.
So the line 20 says
Line 20 as well what?
so now line 20 is dereferencing the address of noun and resident.
All right, so it's dereferencing the address of the noun. All right, that is fine. Okay, all right, so please, the terms here are very, very crucial. Can you get to know the terminologies? Okay, get to know the terminologies. Okay, we have the num. This is actually it's a pointer. Okay. Anytime you have a pointer, you try to dereference them. Okay.
Okay.
All right. So the rest is for us to. I think I've done everything. What's left? Yes. Let's go back to this one. Yeah. Then I will just say something in regard to this, and that'll be all. Okay. So I'm going to implement something right now. Two functions. Okay, let's assume you have a function that's going to return the square root of a number. Okay, so let's have this. So okay, square root of c. Okay, so I have this standard input and it may. All right, so here what we are going to do is we are going to get the concept here properly, call by value and call by reference. Okay. So the first one is we are going to talk about call by value, and you see that. So I think let me modify this and add value to it. Okay, so that will be the end. The rest, I've explained everything. If you have a question, you can just stop me along the way. All right. So I declare my variables. Okay. Right. So here I have ints. Okay, let's assume the person can only enter integers. Okay. So here I prompt the user for input. So I use the put. I say what, enter your number or enter number. Okay. All right. Then I can use my scanf, which is this. Then I have my ampersand, which we know understand now, the ampersand now. So I'll just have my printf, say what, the square root of is or is equal to. And now let's use float rather. Okay, let's use float now so that I have my num over here. Then I have square root num, and I'll pass my num to it. Okay. So let me have my prototype at the top, which is a function prototype, which I'm returning float definitely. Yes. So I have our float, then I have a square root number, then I'll pass some number between it, which is what, int, but I'm only passing this one. So I have this now. Now remember yesterday we learned this. This actually is what? Is the former, right, parameter or former argument, and this is what? The actual parameter. Okay. So let's come here so that I'll be able to declare my thing over. So declare variable. Okay. So I'm going to declare my variable. Declare my function rather. I'm making a mistake. Okay. So I declare my function. And what is the function? Which is returning float. So I have my float over here. Then square num. Then I'll pass some. Okay. Right. So here I'll just go and return what? Square root x. So let me include my mass. Okay. All right, so I have this now. Okay, so here what actually I've been saying all this while is that, you see, we have the actual argument over here, right? This is the actual argument that we are passing to it. Now this actual argument we are passing to it, see, it's just going to what? Return a copy of this. Okay, it's going to return a copy of this. So let's try to understand something over here. Okay, now I'm returning, I can also print, right? So here, this is the value. Okay, this is the value. So let me try to print something, okay, and tell you that what. So I can see the value is, okay, then I can still print my num. All right. Okay, now here, when I come inside over here, I can also print before I return something. So I can print and return of them is correct. So this, let me put my new line over here so that you get confused. Then here too, I could have to print. I say what the value is d, then I also have x. All right. So what I want to show you guys is that we call something call by value and call by reference. We want to get that concept well, and that is where pointers comes in. Okay. So here, what we are passing an argument, which is an actual argument to the function square num. Okay. So this argument that we are passing to it, what we actually doing is that C is just going to return a copy of it, not the actual. Okay. So let me compile this and see what actually happens. Okay. So func, okay. Or I'm coming, no, if there's something I want to do. Okay. This is my number. Okay. Let me do something like that. I think, oh, sorry, this will not work. Let me add some number to this. Let's see. So let me add some number to this. Okay. Then here, yeah. Okay. So GCC, then func square root. Okay. All right. Oh, where am I? I'm lost. Hey. Okay. And then I move forward. Okay. Okay. So let me leave this one to some decimal places for 2. Okay. Yes. Something I want to explain. I'm coming. Yeah. Guys, I'm coming. Give me a minute. Where is it? Okay. I think it's over here. I'll try to. No, this is not what I'm looking for. No, this is not what I'm looking for. Oh, okay. No, this is not what I'm looking for. No, this is not what I'm looking for. You do what? I'm coming. Okay. Oh, looking for something to show you guys. Oh, it's not here. No. No. Okay, yeah. So, yes. Okay, so this is what I wanted to do. Okay, so I tried to manipulate the value. So let me go back and try to manipulate instead of using the square rather. Okay, so here I have my variable and I declare something. Then when I came here, I try to change it. Okay, I try to change it. So there are two things, either you call a thing by reference or you call a thing by value. Okay, so let me compile this, which is, let me go back, CV, and let me run this, my interfan. Okay, so let's look at this carefully. Now I have int A and B, which is 10 and 20 over here. Okay, then I have then when I came to this place, I added and I also multiply. Now let's look at the value over here. Now after the function call, okay, I still printed A and B. Okay, so A and B still remain the same. Okay, it hasn't changed. A is 10, B is 20. So what I did was I just used the function to manipulate. So that was what I wanted to show you guys here. So let me take this one out for that. Okay, I was not getting it correctly. So what I wanted to show you guys was that this variable here that is passed to the function, we are passing a copy of it. So when I run the script, still this one will not change. Okay, it still is going to be whatever I entered. Okay, so if let me go back to group, okay, then let me compile func square. Okay, If I enter 5, oh, I didn't even compile it. Let me come back here. All right, so sorry, ECC func square. Okay, so I've been doing. .c rather made a mistake.
Hello, hello, hello. You are singing loud.
All right, so this is the code I wanted to explain. So here we have a function. I named the code. We want to find the square of a number. Okay, so here I declare my variable, then I tell the user to input. Then here I find the square and I just return. So when I run this script, okay, sorry, not this, ECC func skill. All right. So if I call this, it will ask me to enter a number. Let me enter 9 and to square. Say the square of 9 is 81. This is obvious. Now, this is what is known as score by value. Okay, so here what I was trying to tell you or say that we are passing an actual argument to the square now. This actual argument that we are passing is just a copy of the original value in the memory, just a copy of it. It's not the actual one. So if I try to change anything at all, it's not going to affect it. Okay. So as you can see, I enter 9, but the value is still 9 after the function call. So the value after the function call, right. So let me run the script again, then compile it. Okay. So if I enter 9 again, you see, the value after the function call is still 9. Nothing has changed. Why? Is because the call is what? Is by value. Okay, what she is actually doing is just copying that value and keeping the original one. Okay, this, as I said, things like robotics, things like things that normally deal with embedded system, this is actually limited because you can't talk to the hardware straight away. So you want the one that you can speak to the hardware where you can manipulate the register. This is when this one comes in. Now, I wish I could open this side by side so that, let me see, let me try to split to the right. Okay. So look at the two code carefully, right? And that will be all. I won't go on again. All right. So it's the same thing, but let's look at it. Now, here, let me make it square rather. I think I don't like square root, so I do the same thing here. Here too is the same thing, square rather, not. Okay. So let's look at the code. Now, in the same thing, okay, the only thing, look at line 5 and line 5. What do you see? Oh, let me close this. This one I'm looking for. Okay. Look at line 5 and also line 5 for the other one. Okay. What do you guys see? If you look at it, you see that this one, and look at it, this is a pointer. This is a pointer, but it's not a pointer. Okay, so because it's a pointer, remember we are passing the address. As you can see, look at line 5 here and look at line 5. So anytime we start passing pointers, remember we are passing by reference. So here is passing by value. This one is passing by reference. By reference. Okay. So reference means you will be passing the register instead of the actual value. Okay. Now when you come, it's the same thing, but let's come here, which is the function call, and you see the difference between the two. Okay. Now when I was calling the function here, I just passed what? The ampersand, but here I didn't pass anything. It's only the number that I passed to it. Let's go down and let's look at the function definition. Okay. So if you look at the function definition between the two, what do you see? Here, I just pass the value, only the value, but here I'm passing what? A pointer to it. And even when I was doing the calculation, look at it, this is a pointer. This is a pointer. This one too is a pointer. Okay. This one is just a raw value. This is a raw value. Okay. Now, if I compile this, okay, let me change this, and you're going to see that the values will change. So the value after the function call, okay. Now, let me compile this one over here so that I'll be able to see it properly. Okay. So, which is the func reference, okay. Oh, I've changed it, right? Okay. What I mean, we said what? Undefined reference to square now. Okay, sorry. Here's supposed to be like this. Okay. All right. So I have this. Then let me go to the top. Okay. Now let me enter number 9. Let me press enter. Now what do you see? You see, now this is what I entered. Now You see the calculation is trying to give me. And if you look at the value after the function call, see it has changed. It has altered. That shows you that here we actually having access to the register. It's a register we are actually manipulating now. We are not manipulating a copy of the data. That is why I enter 9 over here. After the calculation, look at it. This, I don't know where this redundant is coming from, but it's still struggling. Okay, now it's struggling from here. Okay, it's struggling from here because because I'm passing a pointer to it, this value has changed. Instead of saying the value, the square of 9, it is 81. And here is referring to some address, and I don't know what is happening. That's why it's giving you this. And when you come down here also, have you seen this also return what? 81. Okay, so this is known as what? Call by reference. This code is not call by reference, but this is call by value. Call by reference, we are manipulating the register instead of the value. Okay, so if you are manipulating the value, just a copy of it. But if you are manipulating the register, you are manipulating the original data. Okay, and that makes this very, very crucial, because if you are building a system and you don't take care, okay, you might manipulate a register that would cause you later on. But this one is much, much more powerful than this, because with the call by reference, you are able to affect changes at the low level instead of the high level. Call by value will replicate data for you, okay, but call by reference will let you manipulate the data in the memory. Okay, but the downside of this is that if you don't take care, you end up manipulating the data that will cause you, okay, later on. But for instead of computing advantage, call by reference is much, much better and faster than call by value. Okay, so how do we solve this? That's the question I want you guys to go and think about it and let me know. How do you solve this? Because I need my 9, but it's still telling me that means I have to take this out, and it's still giving me that. Okay.
Do you remember that song?
All right. Any question? I'm done.
Include.